chi chart, U chart, and fixed sample size and the variables and the NP chart and P chart. They already taught us, sir, by
Very
Minitab.
good. So you want to understand X bar R chart and X bar S chart, right?
Yes, sir. And DOE also, sir. DOE.
Yeah, DOE this week I am teaching. This week, Saturday, Sunday, I'll be with you fully. The last weekend, I had, some urgent assignment. So I was not able to be with you. But this Saturday, Sunday, I'm fully available. So both days I will be available with you, and I'm going to equip you on DOE and the other topics as well. Okay, thank you, Sushil, for coming on camera. Yeah. You want to say something?
And today, sir, sir, today you mentioned the message is a recap the proportion test and chi-square test using Minitab, right?
Correct, correct. Very good. So
So,
that is my
sir,
plan.
okay, sir. Sir, we will open the notebook, sir. For we will open the Minitab first.
Oh, all of you want to open, right?
Yes, sir. Yes, sir. I want to open,
Yeah,
sir.
please open. See, this is the way you must learn, actually, all of you. Not like just, attending the Zoom call. You have to participate. You should also be putting efforts from your side. Those who come out of the comfort zone, they get extra result. Is my statement correct?
Yes, sir. Correct, sir. Of course.
Those who stay in the comfort zone, yes, you will be getting average result. I don't deny. But then you should be happy about what you are getting right now. But if you are not happy on what you are getting right now and you need more, then you have to work more, right? So don't hesitate, first of all, to turn on the camera because this is a way of showing your confidence. For some reasons, yes, we hide our faces, but the other person will not understand all your personal surroundings, right? You are responsible, that's all. If you are confident, yes, people will trust you and get you opportunity. For reasons, if you don't project your confidence, you may lose business, right? So keep that in mind. This is how things work. Very good. I could see now a lot of people on the camera now. Murli, I could see. Venkateshwar, I could see. And all of you can actually, you know, participate fully. Okay. So if you want, all of you can keep your mini tab on. Now there are two things. Actually, my agenda is to discuss the proportion test and then the chi-square test with all of you. But then one of our participant, he asked me, yeah, thank you, Venkat, for coming on camera. And one of our participant asked, sir, let us talk about control chart as well. Very good. And so control chart, and particularly he insisted on X bar R chart and X bar S chart. All right. Now let me try my best to touch all of these things. So starting with proportion test. Okay. First of all, proportion test is a type of hypothesis testing. All of you agree with me? Proportion test is a type of hypothesis test. That means you want to study about one factor. You want to study about a factor, only one factor at a time. Whether a particular factor, right? Whether a particular factor is critical or not. This is the question we want to get answer. What do we mean by critical? Critical means the impact is going to be significant, right?
Right.
If the impact is significant, then what you need to do? You have to be careful with the factor, right? You need to be careful, yes or no?
Yes, sir.
Because the impact is significant, that means we need to be careful. What do we mean by careful? What do you mean by careful? You must have, good control over that particular factor. Am I right? You need to have good control over that particular factor. Don't Don't be, very liberal in allowing the factor to change. Don't allow. Rather, you frequently monitor and frequently tighten the, what you call, the tolerance, and ensure the factor is always maintained in the preferred range. So what will happen? Your result will also maintain at the preferred rate. That is the idea. And in the context of proportion test, the y variable, the y variable, where you see your result should be an attribute. Should be an attribute. What is should be an attribute? Whenever your output variable is like this, yes, no, right? Accepted, rejected, purchased, not purchased. Do you understand? Good, bad. Whenever you have these kind of options, then you need to go for proportion. Say, for example, purchase, not purchase. If you take this, we can create a scenario. Imagine you are running a shopping mall. You're running a shopping mall, right? And you have male customers and you have female customers, right? And 500 male customers came, and then some 700 female customers came, right? And out of these 500, let's say 235, they made a purchase. And similarly, out of this 700, 314 have purchased. Do you understand the scenario? You're running a shopping mall. 500 male customers visited your mall, and 235 out of them, they made a purchase. Similarly, female out of 700, 314 purchase. Now I want to understand whether gender has any impact on the sales. Do you understand?
No.
My doubt is whether gender has any impact on the sales. If I understand the gender has an impact on sales, then which gender is good for my business? I will try to identify whether it is male or female. If I understand it is female, then I will strategize my marketing campaigns. I'll allot more budget on the female audience. Do you get my point? This important decision I can make, and accordingly I can take action. But before I proceed with the action, I need to really ensure, yes, really the gender is critical, isn't it? Otherwise, my strategy may be wrong. I may be unnecessarily, spending my money in the wrong direction, which should not be the case. Are you with me? Now I am comparing two genders, male and female. And so now I need to go for a two proportion test. Very simple. Right? What is the proportion of male? Proportion of male, P1 is 235 out of 500. What is the proportion of female? 314 out of 700. If I ask you, is there a difference in the proportion of purchase? You can do some mathematical calculation and tell me, all of you. In which gender you got more sales? Is it male or female?
Female.
Okay, in terms of revenue, it is. In terms of proportion also, is it female?
May not be.
235 by 500 is how much? And 314 divided by 700 is how much? Come on, one of you can help me. 235 by 500 is how much? And 314 by 700 is how much?
265, sir.
235 by 500 is?
265.
How can it be 265? 235 divided by
235
500.
divided, sorry, divided by 500. 0.47, sir.
Okay, 0.47. That means almost 47% of the male
Yes, sir.
have made the purchase. Similarly, for female, what percentage?
45%.
45%, sir.
45.0. You can tell me the right figure also, right? You don't have to round off.
0.448.
45.44. Okay, at least 2 decimal.
44.
So here then, okay, 0.47. Okay. Then here it is 0.45. You are right. Okay. In this way, 2 decimal is fine. Okay. So now what do you think, all of you, looking at the numbers? Do you think really gender is critical, or can you target both genders? Which is good?
Both of them.
What do you think, all of you?
Both of them.
Yeah, my common sense is telling you don't have to differentiate the gender, right? You don't need to have different strategies. You use the same strategy, it's more or less same. That's my common sense is telling. But still, if you want to be very scientific, you can use data and then proceed with the two proportion test and get your common sense information confirmed scientifically. Clear, all of you? Now it's a two proportion test. What I do is I go to stat, I go to basic stat, then I go to two proportion. Now look at the description. Determine whether the sample proportion of an event for two groups differ significantly. What is the event? A client or a visitor making a purchase is the event. There are two groups, male client, female client, right? What is the proportion they made, right? So I click two proportion. And now I don't have really data here because I'm only giving you the description, isn't it? I'm only giving you the summary of the event. You may have a raw data. If you have a raw data, yes, you can use this option. But I don't have raw data. I have the summary. Now first event. Let us do it for male. 235 people purchased. Out of how many trials?
500.
500. And female, 314 have purchased out of 700.
700.
Now I click option. Here I need to declare what is the confidence level with which I have to make a decision, right? Normal practice is 95%. If you want to increase, you can change it here, 99, or you can change it to 99.9, whatever. But normal practice is 95. When I say 95, what does it mean? What is the amount of uncertainty I am admitting?
5%.
5%. What do we call it as? Alpha risk. Alpha risk is
5%.
agreed to be 5%. Now, hypothesize the difference. What is hypothesize difference? Difference in the proportion between sample 1 and sample 2. Sample 1 is considered as male. Sample 2 is considered as female. Male proportion minus female proportion is equal to 0. That is null. Not equal to 0 is alternate. When I say alternate, when I say not equal to, it becomes a kind of two-tailed test. You can also keep it one-tailed, left-tailed or right-tailed. But now I really wanted to understand whether the gender is critical. That's it, right? So it's a two-tailed. And test method, different methods, any method you can use, choose anyone. Give okay. I think you all understand all the options I have selected here, right?
Yes.
Now you give okay. And you give one more okay. Our expectation is, what is the p-value of this data? If the p-value of the data is below 5%, it is telling you that the difference in your data is statistically significant, or other words, scientifically significant. So you can read the data, whatever is the finding, that can be now vetted with your common sense, and then you can declare. If p-value is not 5%, you have to base your conclusion completely on the common sense. You are not supposed to use the findings of the data, findings from the data. Are you with me on this?
Yes, sir.
Yeah. So I click OK. And now Minitab has done the two proportion test for us. You can see all the test and confidence interval for two proportions, right? And whatever data we have given, that has been summarized here, and everything is written. Now look at the p-value. Please let me understand whether p-value is below alpha or above alpha. P-value is more than 0.05, isn't it?
Yes.
So hence, the difference observed in the data is statistically insignificant. Hence, your conclusion will be purely based on the common sense. Now you know your business very well. You know your customer very well. Now you decide. You don't have to believe the data right now. You decide. Tell me, focusing on particular gender is good or focusing on both gender is good. If it is particular gender, whether you want to focus more with the male or focus more with the female. This is the decision you are taking. Now, who is completely responsible as well as accountable for the decision? You are yourself, your common sense. Are you with me? All of you?
Yes, sir.
And if I am in that situation, I will not consider gender as a critical factor. I will prefer to run the campaign targeting both genders. Yes or no?
Yes, sir.
Now look at our participants here. What do you think, all of you? Gender is critical to Lean Six Sigma training. You see, all the
No.
faces are male. Everybody on the camera are male. So female very less, isn't it? I could see only one madam here, Dhanalakshmi madam only attending. But I could see a major difference in the proportion of male participants and female participants attending our program, which is giving me an important piece of information. You know what is the important piece of information? Our campaigns must focus on male candidate. Yes or no? Spending 1 lakh with the male audience can get you more business. Spending the same 1 lakh with female audience might produce only less business. Which is favorable for you? Tell me. You want to spend with your male audience or female audience? The data says, you get only meager result, isn't it? Out of 30, 40 people, 2, 3 female candidates are joining. So why should you unnecessarily waste your money? And difference seem to be very significant, yes or no? You really don't require any statistical analysis because your faces directly tell me. You focus on the male, isn't it? But whenever data is very close, it's a close call. You should definitely be scientific. Am I correct? All of you, do you understand when do you need these kind of analysis, when you do not require these kind of analysis? For a situation right now, do you need statistics to decide?
No.
Not required. Everybody is, majority, more than 80% of the participants are male participants. So the situation is, doesn't really require any analysis. Even if you do the analysis, p-value will be below 0.05. Automatically, you do the same proportion, apply the same proportion. Now let us take how many people? 15 people, right? Out of 15 people, 4 people are men. And 1 candidate is woman, right? So let's do that. Total participants, how many? 15. Out of that, male is how many? 14. I'm adding myself also to support all of you, right? 14. And then the female candidate, 1. Now, what kind of test I should do now? What is the test I should do now? What is the name of the test? Come on. Which hypothesis test I should do? Come on, yeah. Why are you hesitating? Unmute. You want to go with 1 proportion, or you want to go with 2 proportion, or you want to go with 2 sample t-test?
One proportion is.
Which 1 proportion? How is it 1 proportion? How many groups of data you have? You have 2 groups, right? Male and female.
2 proportion.
You should call it 2 proportion test. So 2 proportion test, or shortly known as 2P test. So let's do this. Tell me, where should I click?
That
Okay, stat. Basic stat. Okay, basic stat.
Basic stat, it is
Two proportions.
two proportion.
Okay, two proportion.
Summarized data.
Very
Data.
good. Right now, I only have summary, so I should choose this.
Data.
If you are, if I
Summarized
have
data.
a raw data, then only I should do that, right? So this is summary. Now tell me
Summarized data.
sample one. How many sample one is male? Let us assume sample one as male. How many male here?
14.
14.
What is the trial? Trial means total
15.
15. And female one
15.
out of 15. And option 95, 0, same thing. Okay. One more okay. What is the p-value?
0.0.
That
0.0.
means the situation is telling me a very, very valid piece of information for me. If I have a budget of 1 lakh, probably 80,000 I will spend on male audience. 20,000 I will spend on female audience. This is my common sense. Please understand. 80,000, 20,000 or 90,000, 10,000 or spending all 1 lakh on male. This is my common sense. This is how now real time we take decision. But statistics, from the background, it is giving you some valid piece of information. What is the valid piece of information you are getting? Gender is critical to your business, or gender is critical to your process. Now it is purely your common sense, which will allow you to decide how much to spend on your campaigns. Clear, all of you?
Yes.
Yes.
And over and above the what you call the regulatory guidelines and all that, you need to follow that. That's why I'm saying it's common sense, right? Suppose if the regulatory, for example, Facebook policy is you can't run campaign where you should not discriminate your audience based on the gender. So these kind of constraints will always be there, right? So that you tackle it. Now, what is raw data for the same thing, right? So I will tell like this. Candidate roll number. And next thing is gender. How many roll number I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And I know when I actually collect the data, it is going like this. Everything is male. Only one candidate is female. Now I want to check whether same thing, I'm giving it in the form of a raw data. All right. So basic stat, two proportion, instead of summary, both sample are in one column. Now where is your sample? Gender is your sample. What is the sample ID? Roll number is your sample ID. Now go to option and everything is same. Nominee tab will automatically count how many male, how many female. Oh, there must be exactly two distinct subscript. Okay. Correct. Okay. Male, female. That basic stat, two proportion. Each sample in its own column. I think, okay, this is, okay, instead of roll number, I would call it group, right? And these are all one group. All male are one group. This is another group. Let me check. Stat, basic stat, to proportion. Hmm. This has to work. Now it is working. That means, we need to compare only two groups, right? When I put 1 to 15, then it divide, it considers there are 15 groups. So what do we get here? P-value of less than 0.05. That means it is significant. Significant means the gender is critical. So you can proceed accordingly. Likewise, you can use this test for any similar scenario. Are you able to correlate this learning with any of the scenario you have come across in your field? All of you?
In this instance, it is showing 0.067, right? 0.06
Yeah, it's more.
greater than.
It's greater than, right? Okay. Why is it coming Fisher's test? You're right. So it is 0.067. That means at 5% level of significance, it is saying that we cannot say the difference is no significant. But according to Fisher's exact test, which means, sometimes it may mean the sample size, what we considered, is not sufficient. Probably we may have to consider more sample. Let me double it. I'm adding one more set. Stat, basic stat, and to proportion. Yes, that's done. Gender and group. Options. So see, before arriving on the p-value, it considers many things. One is the actual, the difference in the proportion. Another one is the number of samples considered for study. See, and moreover, it depends on the type of test also. You see what is the name given here? Fisher's
Exact
test. So in statistics, there are multiple methods available. So it's like using different vehicles to reach a destination. So each one has certain plus and minus. Same manner, according to Fisher's test, you need a considerable amount of samples. Then only what happened, the p-value will go below 0.05. The earlier one, it was almost close to 0.05, but then strictly speaking, it was above 5%, and so we have to ignore. But again, as I already clearly told you, finally the conclusion is your common sense, your call. What is the situation? What the statistics is telling you, and what your common sense is telling. Accordingly, you can say. Okay, so now can a few of you tell me a real-time scenario where you can use this study in your domain? I have explained, how I can use in my domain, isn't it? I can use in my domain to understand whether the gender is critical to the, what do you call, enrollment, isn't it? Instead of working with 100 female leads, if we contact maybe 100 male leads, we might get more enrollments. Yes or no? That is the message. I can use it in my business. How about you? Can you tell me one example? You may be into manufacturing. You might have two machines. Yes or no? You might have two machines, and the rejection record might be available with you. Am I right? Machine-wise rejection record. How many parts you produced using machine number 1 and how many parts got rejected? Similarly, how many parts produced with machine number 2, how many got rejected? And now you are testing whether machine is critical to the rejection or not. Yes, sir?
Yes, sir.
Whether machine is critical to rejection or not. The moment you understand machine is critical to rejection, you have to identify the culprit machine, and then probably you need to do some service or whatever. Right? So two proportion test can be used. Can you compare two assembly lines? Yes or no? Two assembly lines. Assembly line 1 and assembly line 2. But your data must be attribute. How many times the assembly line 1 is affecting on-time delivery? And what is the on-time delivery rate for assembly 2? That becomes a case of two proportion test. Yes or no? You have two departments. HR department, maybe some department, two departments, right? You are comparing. But you are comparing based on an attribute data. That is very important. If you consider a continuous data, then the scenario will be considered as t-test, isn't it? Two sample t-test. Attribute means percentage. What percentage of the time department 1 has succeeded, and what percentage of the time the department 2 succeeded? Succeeded can be anything, on-time delivery or the what do you call maintaining the meeting the customer requirement, something. So two proportion test. Please confirm, all of you. Are you understanding anything here with these examples of two proportion test?
Yes.
Your silence is disturbing me, because this has been taught to all of you on Saturday, Sunday, isn't it? I am only recapping now.
Yeah.
I'm recapping and trying to simplify, trying to break down. How can you use this test? Tell me you have a boy and a son and daughter. You have two kids, right? And the what do you call this one now? And the
Can we use
person.
uh, sir, one question. Can we use this test for looking into the ROI of two different projects?
ROI is a measure. ROI is considered as percentage, right?
Yeah, I'm just saying if project
ROI, very good. ROI in terms of percentage, yes, can be compared. If there are two groups or two factories or two projects where you are comparing ROI, it can be a two proportion test. To solidly say projects of type 1 has a better ROI, you can conduct a two proportion test, and if you have a lower p value, you can say project of type 1 gives you better ROI, significantly better ROI. Good.
one more question. In the exams that we are going to perform, this black belt exam, do we need to use Minitab or is it only online objective only?
Up to you. We are giving you full freedom. And utilizing the freedom is yours. It's an open book exam, right? You can use any of the resource that you have.
Okay.
You can also appear for the exam without any resource, just with your mobile phone also.
Do we need to perform calculation in Minitab and update, or that's what I was trying to understand?
Very simple. You want to use, you use.
Okay.
Right? Don't want to use, no problem.
Okay.
So
Right?
without using, like as sir asked, as the other sir asked, so without using Mintab, how would he come to know to the answer?
I just now explained. Minitab generates the report. You just have to look at the p value.
Yes.
And if the p value is below 0.05, then the statistics is having a significant piece of information. Based on the information, you have to take a decision. Correct?
No, yeah, I understood that, sir. So as as he asked, so like during the examination, would we have questions where we need to use Minitab to come to a
Yeah.
solution?
We will only have questions. Whether you arrive the answer using Minitab or arrive the answer using hand calculation or arrive the answer using Excel, it will not be mentioned.
Oh,
But there will be some questions definitely demanding your skills in the analytical areas. But if you just attend all the classes and also put some effort, and for sure you will be able to answer all the questions. Then also you will be on the safe side only. Don't worry, right? Don't worry too much about the exam, but try to equip yourself as much as possible. This is not, I'm not preparing you for the exam right now. I am preparing you for to face the real time scenarios.
We
You're doing a
understand.
project, you are facing a scenario in your company, and that time your boss is expecting you to come out with a solid decision. For that time you use this tool and then do it. And the manual calculations are also there. Those who do not have Minitab, do not have Excel, do not have any mentor, they have to do everything on their own. Manual calculations were also there. But explaining that will be very boring. So we stopped explaining all of those things.
So one more thing, so after the sessions are over, I think by next week, this week, the sessions are over, right? The 30th.
Yes, correct.
So if we have questions or maybe some sort of suggestions, the recommendation that we require, some sort of assistance in the practical situation when we face, can we reach out and ask for some sort of guidance?
See, all Thursdays, 8:15 p.m., we will be available. Yeah, myself or RK will be conducting. You can join any of the session, right? And you can also reach out to us if there is anything really serious, important you wanted to discuss. Yes, we'll be open to it. And you can also continue explore, continuing your learning. Like then there is one more level where we'll be discussing more of the practical scenario, like master black belt, where we expect you to work on a real-time project,
mhm.
either a completed project or a new project, right? And you need to work on a project and try to apply these tools while driving a project. And then end of the course, you yourself will be presenting a excellent case study to other participants, and that will give you a lot of confidence. So ultimately, you all have to come out of your comfort zone and put something, some effort on your own and put yourself into a challenging scenario. But slightly after putting the letter, after some time, you will certainly feel proud of your efforts, no doubt. And we are going to help you. And even this course also, next week there is an exam. Now you might be feeling some pressure, but after the exam is over, you will feel delighted about your efforts. So don't worry about it. It's part of the process. Exam is part of the process. We are preparing you. We are preparing you. The exam sessions will be conducted again next Thursday. Exam session will be conducted. We've already shared the mock questions. Explore those things, and in any case, you will be on the winning side only. But if you're serious about real-time results, like some results you wanted to see in your life, then you need to capitalize on all these opportunities. If you
Mark
are very,
questions.
very strong, any interview, you will be the winner. People will see your confidence on the face. Oh, he is very comfortable while discussing two proportion tests. So he is the right candidate we are searching for. That's all. They're not going to be worried about your answer.
The
Yes,
mock questions are shared in which batch? Is it any?
same WhatsApp group, same WhatsApp group. Maybe it is there in the group description as well. It's there in the group description as well. Okay, I'll put it one more time. Since you raised this question, I'll put it one more time. It's there. 1 minute. OLGV BB66. Preparatory exam. You can see it in the group now. And similarly, another group, BB16, I believe, right? Not 16.
Maybe 66.
BB
66.
66. 60? Come again, sir?
66, sir. BB66.
Oh, 66, just now I posted. Now the other one is 17, I believe, right? 17 or 18? I think 18. I'll put there also.
18.
Yeah, there also I'm putting it one more time. Try all these questions. I have also explained analytical questions in a video format as well. That link also given. Watch that video. And over and above, finally, if you are fully prepared, take one paid mock exam if you wish. Then you get to understand where are you and then you can proceed. All right, so this is very clear now. Two proportion test is clear, right?
Yes,
Yes,
sir.
sir.
Very good. Now we'll go for chi-square test. I'll show you. So chi-square test. When to go for a chi-square test? When you are comparing only two groups, male, female, assembly line 1, assembly line 2, imagine there are 10 assembly lines. 10 assembly lines, and in all the assembly lines, rejections are happening. Now you want to understand whether rejection is abnormally high or low in any particular assembly line. Now, how many assembly line you have? 10. If it is just 2, it becomes a case of two proportion test. If it is any number more than 2, you can go for a chi-square test. Chi-square test. ANOVA also good.
Yeah, that's why I was
What?
trying to ask the question.
Yeah.
Whether you can go
ANOVA
for-
is also good. ANOVA for measurable data. We are talking about percentage rejection. We are not measuring. We are only counting. If you measure time, if you measure surface finish, then it is certainly ANOVA. Since you are not able to measure, you are only counting, chi-square test. Because non-measurable data are known as attribute data.
Okay.
Correct? So, chi-square test, right? I'll show one example for chi-square test. For that, I am taking you to the sigma level calculator because there is a data file available. Questionnaire defective. See here, I have 4 regions. I have 4 regions. Insert. And this is my north, and this is my south, and this is my east, and this is my west. 0 means no problem. 1 means there is a defective. Do you understand? So 1 refers to a failure and 0 means all good. So now I want to understand, is there any particular region my team is making more failures? That is my doubt. And how many office I have? I have 4 office. I have 4 teams. Very often complaints are coming from all the zones. You can see everywhere there is one coming. But now I want to understand whether any particular office, the mistakes they commit is significantly higher. That is what I want to understand. Right? So what I do is, this definitely relates to a chi-square test. Yes or no? Because 4 types of groups I have. I copied this. I am going to Minitab. I'm just pasting it here. Clear? North, south. And why do I say it is chi-square, not ANOVA? Look at my data. It is not a measured data. It is just an information. There is a customer complaint received here. And there is, customer complaint received here. Now I want to understand the proportion of complaints received. Is it significantly higher or not? And now what is the null hypothesis here? Proportion of customer complaints are equal.
Okay, yes.
Alternate will be
Not equal.
unequal. That's all. And now the test we should perform is chi-square test. The reason being, there are 4 groups, isn't it? So, but in chi-square test, we need data in just 2 columns. We need data in just 2 columns. One column indicating which office it is, north or south. Another column indicating the result, whether it is 0 or 1, right? So I need to convert the 4 columns into just 2 columns. For that, I am going to data. There is an option known as stacking. Stack the columns. These 4 columns I want to stack. Just modify. And the stacked information I want in the current worksheet, let me say I need it in the column 10. And the name of the office in column 9, subscript. And look at what happens now. Can you see here? Right? And this is about maybe some stat. Oh, sorry. Okay. So here I'm typing whether the status, good or bad, something. So now I need to perform chi-square test. Go to stat, go to table. There is cross tabulation and chi-square. You click that. Now rows nothing but represents your office, and columns nothing but your status. And now chi-square, you click that, click, check this chi-square test, and these informations if needed. So okay, and one more okay. And now the test is done, and p-value, look at the p-value. How much it is?
160.
P-value is more than 0.05. Hence, the difference is insignificant. That means all the 4 regional offices are performing equally. Now you are the country head. Do you want to take any action under this condition? Do you want to find out, who is really doing bad, and then you want to put some penalty? No, don't do it. Even if you see some difference between actual data, if you look at, I will also show you the actual data. You go here, it will count and summarize. You see how many customer complaints from east office? 22, north 25, south 21, west 17. Now which office attracted more complaint?
Not.
And which office, which zone performed very well?
West.
But you are not supposed to talk like this. You are saying just you are looking at number, but you are not really using statistics. Yes or no?
Yes,
If
sir.
you use statistics, you will not make these kind of conclusion. What kind of conclusion?
Based on numbers.
West is very good. You will not say that. And north is very bad. That also you will not say that. You know why? P value is more than 5%. When P value is more than 5%, you are not supposed to, take actions based on the numbers. Your action should be based on your common sense. Yes or no? Are you with me, all of you?
Sir.
This is known as proportion test. Is it clear? And don't worry about the procedures which you can learn any point of time. Maybe one-on-one I will teach you. If anybody want to do the calculations manually, you want to go 10 years backward, no problem. That is separate. But now rely on the report, right? Situation, proper analysis, and the report. And how to read the report, and how to interpret, and how to take an action in real time. Whether an action is required or not. In the case I have discussed, action is not required. If you take action, you will be wrong. Correct?
Yes, sir.
That's all. So sometimes it's good to take action. Sometimes it is good to stay silent. Wait for some more time to actually make a conclusion. Now data is not really sufficient enough. You are not really able to prove anything. According to the industry practices, we are not able to prove that a particular zone is performing well or a particular zone is performing bad with the available data. Maybe it's reasons, data insufficient or something. So that is why p-value is not really going below 5%. All right. So I will do only one control chart and then conclude this session because one of our participants asked for the control chart. Who asked the control chart?
Me only, sir.
Murali. Okay.
Yes, sir.
So X IMR you finished it, and X bar R
Sir, yes,
chart,
sir.
X bar S chart. Which one we can
Yes, sir.
discuss now? X bar R chart.
Yes, yes, sir.
Okay, that's the easiest
Sir,
one.
by many tab, sir.
Mini tab only. Don't worry, mini tab.
Okay.
So some data is required. So let us go to the Excel file. Let's take some relevant data. See here, what is this cutlet diameter? All of you know cutlet, right? Vegetable cutlet. Imagine you have a cutlet making machine. You have a cutlet making machine, and that cutlet is actually, that machine is making vegetable cutlet around some 7 centimeter. Can you see the diameter here? Cutlet making machine A. What is the diameter of the first cutlet? 6.8 centimeter. This is 6.4, 6.9, 7.3, 7.4. Requirement is 7 centimeter cutlet. Are you with me, all of you?
Yes, sir.
Requirement is 7 centimeter, but the process you follow is bringing variation in your cutlet diameter. If the cutlet is becoming too small, customer might question you. If the cutlet size is too big, that may be, maybe the cost wise it may be more, some reason. So anyway, the variation must be controlled. So in order to keep this process under control, the cutlet making machine is continuously producing cutlet. But every 30 minutes once, you are taking, how many samples here? 36. Okay. Every 30 minutes
30.
once, you have taken 3 samples. Every 30 minutes once, you have taken 3 cutlets and you measure its diameter and you recorded it. Now, how many data points you have? 36. That means how many times you have taken the sample?
36 times.
12 times you have taken the sample. So I just copy this. I'm taking you to Minitab. I'm placing my cursor here and paste it. Oh, sorry. Data means I should place here, and here I have to type what is this. This is cutlet diameter, right? And now tell me, what is the sample size in this scenario?
7.
Sample size
3.
is
12.
3, right? But I have taken these samples how many times?
36.
36 times.
No, number of 12 times I have taken sample. Number of subgroup is 12 and sample size are subgroup size is 3. Are you with me, all of you? And
Yes,
the
sir.
sampling frequency is 30 minutes once. This is logically decided. Now, which control chart I should go for? X bar R chart.
Acha.
Why this X bar R chart? First reason, the data is continuous. The data is continuous. Are you with me, all of you?
Yes, sir.
Continuous means what? Continuous means it is measurable. Another reason, my subgroup size or sample size is less than 8.
8 to 10.
Right? You can go up to 10. Up to 10 also, it's a normal practice. Nothing wrong. You
Yes,
can
sir.
use X bar R chart. So how to plot that? Go to stat, go to control chart, variable chart for subgroup, X bar R chart. Stat, control chart, variable chart for subgroup, X bar R chart. You click that. All observations are in one column. Tell me,
Okay.
you have the same method only, isn't it? Your data is available in that method only. So you click here and choose that column. And this is that column. You choose. And it is asking you subgroup size. What is your subgroup size?
3.
You took 3 cutlets. And what are the control chart test you want to apply? And depending on your, understanding about the process, I am going for all tests. Okay. And one more okay. And now Minitab is doing the magic. And look at the process and tell me. The process seems to be normal. Can you see that?
Yes.
Yes, sir.
Normal in the sense, your data is always in the same range. Whether it is good or bad, that is a capability analysis. That is different. But your data seems to be normal. It lies within the expected range according to the variation in the data. But your control limits seem to be wider. Can you see here? 7 mm is what? No, 7 centimeter is what you are targeting. But your
7.6.
process has a chance to go as high as
7.6.
7.6 and as low as 6.4.
6.4.
And there are 2 control charts. Can you tell me why there are 2 control charts?
Average range.
Why there is average, why there is range? The range represents what? The range represents the variation in the cutlets you produce within that 30 minutes. Depending on the machine capacity, within the 30 minutes, some machines might produce 500 cutlets. Some machines might produce 5,000 cutlets. I don't know. That real time situation you need to understand. But the data is telling me the range is under control. Whether the machine is producing 500 cutlets or 5,000 cutlets, all of them are diameter-wise close to each other. Can you tell me? All of them diameter-wise, they are close to each other. That is getting confirmed by the R chart. This is known as variation within 30 minutes. Within variation. All the time you took the sample, the variation is under control. Can you see that? This is known as within variation. Are you with me, all of you?
Yes, sir.
Yeah. Now there is another control chart. Another control chart known as X bar chart. This is known as between variation. This is known as what? Between variation.
Between.
What is between? First 30 minutes, what was the diameter? Next 30 minutes, what is the diameter? And subsequent 30 minutes, what will be the diameter? Do you understand? Past, present, future. First 30 minutes, second 30 minutes, third 30 minutes, fourth 30 minutes, 12th 30 minutes. This is your period of study. Every 30 minutes, the average is found to be under perfect statistical control. Can you see?
Yes.
Imagine one particular slot, the operator made a wrong setting in the machine. Let us say third 30 minutes, operator made a wrong setting. So the size of the cutlet reduced, abnormally small. Do you understand?
Yes, sir.
Then what will happen? The third average will be shifting beyond control limit.
Down, beyond level. Okay.
It might go below or above. Above means, because of the depending on the setting. Whenever you see an average going below control limit or above control limit, you can understand something went wrong in that particular slot.
Yes.
If the machine has produced 5,000 cutlets in that slot, now you have no option. You have to 100% inspect all 5,000. You know why? Because the average got shifted. Can you see that? If the average is shifted, this is a serious issue. This is creating a lot of doubt about the quality of the 5,000 cutlets you produced in terms of the size. And how will you validate? You have to do 100% inspection. Are you with me?
Yes, sir.
Yes.
This is the use of X bar or chart. Within variation, another one is between variation. Within is R chart, between is X bar chart. Okay? And tell me all of you, today 8:15 we started. Now it is 9:15, right?
Yes, sir.
All of you are now getting a nice sleep because it is after 9 o'clock and you will find more sleepy now. Now let us divide our program into 15 minutes each. First 15 minutes, what is the condition of the participants? Next 15 minutes, what is the condition of the participants? Third 15 minutes, what is the condition of the participants? The last 15 minutes, and everybody slept. I see an abnormality in the fourth slot. Yes or no?
Yes, sir.
Now I will make a change. Fourth slot, if you want the class to continue, you should be on the camera. Otherwise, I am not going to take the risk. So you need see, and there is also within variation, isn't it? Within variation, within variation. First 15 minutes, if you see more people on the camera. But second 15 minutes, it's different. Third 15 minutes, different. So I see a between variation. So control the between variation as well as control the within variation. You know what is within variation? Within the 15 minutes, everybody should be active. Yes or no? Then only your process will be delivering the requirement. Otherwise, so there is within capability as well as between capability. Within capability depends on within variation. Between capability depends on between variation. That is why from the R chart, we derive sigma using the formula R bar by D2 and calculate CPCPK. CPCPK is always within capability, right? We will talk more about the same thing because I will be discussing with all of you CP, CPK as well as PP and PPK on the coming Saturday, Sunday class. Saturday, Sunday, don't miss 3 p.m. to 6 p.m. I will be discussing two important topics with all of you. One is, one more time, the process performance indices and process capability indices, which is very, very important topic, very often getting confused in the real-time scenarios. And so it is discussed in the interviews, right? Another thing is design of experiments. So don't miss, and we'll be meeting on Saturday, Sunday. All right. You learned something today, all of you?
Yes, sir.
Sir.
Okay. Well done. So we'll be meeting this weekend. Thank you. Bye-bye. Good night.
Thank you, sir. Good night, sir.
Good night.